Welcome to this short presentation about passive filters. This is supposed to be submitted as an assignment for my EC 206 course, that is Network Theory. I am Sujal Kumar, and today I will talk about passive filters. Before jumping to passive filters, let's talk something about filters. Filters are frequency selective circuits which are used for filtering out some of the input signals on the basis of their frequencies. These are basically of two types, active and passive. Actives are the ones which use components like op amp, transistors, etc. in addition to R and C, while the passive ones make use of passive components like RLC, resistors, capacitors, and inductors. Now, coming to passive filters, here are some features. First up, they are made up of RLC, as I have discussed earlier. Then we have that they do not need any external source of energy. That means there is no voltage gain whatsoever across it. Again, the output voltage is always less than its input voltage. One thing to note is that they can easily filter a high frequency signal but cannot process any low frequencies. So that's a drawback. Coming to the types of passive filters, they can be classified on the basis of frequency response as low pass, high pass, band pass, and band reject. We will discuss all four of these in detail separately. Let's start with low pass filter. So this is the one which passes low frequencies and rejects the higher ones. If you look up the graph, you can see that on the x-axis we have frequency and on the y we have voltage gain. If you notice carefully, after a certain point of frequency, the gain suddenly drops and eventually becomes zero. So we select that point so that all the frequencies before it are passed by the filter, and the ones which come after them after that point are rejected. Now if we take up the transfer function, that is h omega, and put 0 and infinity over there, we will get 1 and 0 respectively, because at lower frequencies the gain is substantial, it is there, while after a long period of time, a long frequency, it will become 0. A high pass filter is just the opposite of a low pass. It passes high frequencies and rejects the lower ones. As it is clear from the graph, if you look up towards 0, the gain is also 0. But after a certain point, it suddenly rises and then continues to be constant. That means if we have the transfer function and put 0 over there, it will return 0 only, while at infinity it will be 1. Unlike low pass and high pass filters which work over a point, the band pass filter works over a whole frequency band. So it passes frequencies within that specific frequency band while blocking all the frequencies outside that band. We can look it up from the graph that there are 2 points between which all the frequencies are getting passed while others outside them are getting rejected. So if we analyze the transfer function, it will be 0 at 0 and again 0 at infinity. Finally, coming over to the band reject filter, we can understand this one through the analogy we use to understand low pass and high pass. This one is just straight opposite to the band pass filter. In that one, the frequency band that is specified gets passed, but in here it is the one that gets rejected, while the frequencies outside the given band are passed easily. So the transfer function returns 1 in both cases, that is h at 0 and h at infinity. Moving towards the end, here are all the circuit implementations of the respective passive filter circuits. They couldn't be discussed in detail in this video as it would get too long to handle. So I am just leaving it at this. Finally, thank you so much if you have really made this far to the video. It really means a lot to me. Actually, it's my first voiceover presentation, so of course there will be mistakes here and there, but I'm open up to suggestions. Again, thank you very much.